Okay, so on this first one, we have what times what would give us negative 99, but then add together gets you 2. Negative 9 and 11. Okay. What times what would give you 78, but add together to get you negative 19? Say it again. Okay. And on the next one, what times what would give us 98, but then add together to get me 21? 14 and 7. Okay. Again, this is going to help you in this next part of the unit. So if this is something that is uncomfortable or you don't have those multiplication skills. Okay. So there are 2 different forms that we're going to talk about. So we've been talking about quadratics, and there are 2 different forms. There are 2 different forms that we're going to talk about. Okay, so right here, we have this 2x squared plus, 2x squared plus 8x minus 10. So this has descending exponent order. Okay, so when we talk about so standard form is descending exponent order. Okay, so we go from the 2, then to the 1, and then this guy doesn't have an exponent, right? Like it's x to the 0 power, which would just be 1, right? Okay, so right here, we have 2x squared, 8x minus 10, and then when we put it all together, this is what we get. Okay, so what we're going to do is we're going to take negative 1, and we're going to plug it in for each piece. Okay, and then we're going to combine it to get our last piece. Okay, so if I take negative 1 and I plug it in, what am I going to get? So negative 1 squared is 1, and then 1 times 2 is what? 1 times 2 is 2. On the next piece, we've got 8 times negative 1. 8 times negative 1 is going to give us negative 8. This next piece, it's just negative 10. So if we combine all of these numbers, if we do 2 minus 8 minus 10, then that's going to give us 2 minus 8, which is negative 6. Negative 6 minus 10, which is negative 16. We're going to try the next one. We're going to plug in 1 into this equation. So we got 2 times 1 squared, which will just give us 2. 8 times 1, which is 8. And then negative 10. We're going to combine these things. So we're going to say 2 plus 8 minus 10. And when we do that, we get 0. So the points negative 1 comma negative 16 are on the graph. And 1 comma 0 are on the graph. Now, factored form, this is going to help us tell the x-intercept. Okay, and we're going to talk about that in just a second. But this is going to help us with telling our x-intercept. Okay, so standard form has descending exponent order, and then factored form is going to have our x-intercept. So on this one, we're going to plug in negative 1 into this equation. So 2 times negative 1 minus 2. What's that going to give me? 0. 2 times negative 1 is negative 2. Negative 2 minus 2 is negative 4. On the next one, we're going to plug in negative 1. The negative 1 plus 5 is going to give us 4. So we have negative 4 plus 4. Or I'm sorry, times 4. Okay. Negative 4 times 4. That's going to give us negative 16. Notice how that was the same answer on the last equation. On the next one, when we plug in 1, we're going to get 2 times 1 minus 2. 2 times 1 is 2. 2 minus 2 is 0. And then when we plug in 1 into this equation, we have 1 plus 5, which is 6. So when we multiply 0 times 6, that's going to give us 0. Again, same thing that we got on the last one. So some things we want to remember. Is standard form is going to be ax squared plus bx plus c equals 0. Factored form is going to look like x plus a times x plus b. Okay, you could also say x minus a times x minus b. That's fine too. We're going to see what that means in just a second. Remember, factored form is going to give us our x-intercepts. But both of them give us the same equation as long as they're written the same. We're going to learn how to break a standard form down into factored form. So that's going to be a little bit later. Okay, so you might have plugged in something different, and that's okay. So let's go ahead and start talking about it. So you might have plugged in like -3. If you plugged in -3 into this equation, okay, you're going to get something that looks like this. So -3 squared is going to give me 9. -2 times -3 is going to give me 6. And then we're going to have -6. So that would have equaled 9. Okay. What's another x value that you can plug in there?
3.
Why is it 3?
Yeah.
Okay. If I plugged in 3 into this equation, this would have given you 9 minus 6 minus 6. And that would have given us 9 minus 12, which is -3. Okay. What's another x value that you had?
2. I say -2.
Okay, if I plug in 2, that would give me 2 squared minus 2 times 2 minus 6. That gives me 4 minus 4 minus 6. So that's going to give me -6. What's one more? Huh? 1. So if I plug 1 in, I would get 1 squared minus 2 times 1 minus 6. So this is going to give me 1 minus 2 minus 6. So that's going to give me -7. Now, you could have plotted these by using Desmos, or you could have done it by hand. But if you would have done it by Desmos, then you would have plotted -3, 9. You would have plotted 3, -3. You would have plotted 2, -6. And then you would have plotted 1, -7. Okay. So if I zoom out, I can kind of see that there's like a parabola forming right here. So it kind of looks like this somewhere, right? However, what I could do is I could just come in here and type the equation. So x squared minus 2x minus 6. And look at that. That's very similar to what my quadratic that I just drew was. Okay, I've taken the same numbers. Okay, so you could have plugged in something different. And I'm going to simplify and plug in. That's going to give me 3 plus 4, which is going to give me 7. And then 3 minus 2, which is going to give me 1. On this one, hopefully you didn't make this mistake, but you have 7 times 1, which is going to give us 7. Not 7 plus 1. Okay. On the next one, when we plug in -2 plus 4, that's going to give us 2. And then -2 minus 2, which is -4. 2 times -4 is going to give us -8. Okay, again, we could go into Desmos and we could plot this. And we would get this. Okay. So if you didn't get that down, go ahead and take them. Okay. So what did they do correctly? Well, let's just kind of work through this. If I took 5 and I plugged it in here, then I would get 2 times 5 squared. 5 squared is 25. 2 times 25 is going to give me 50. Okay. On the next one, if I plugged in 5, I would get 5. On the next one, I just get 1. So what's 50 plus 5 plus 1?
56.
Okay. So that's what you would be writing down at that second draft. So what was their mistake? Well, they plugged in this mess and got 100. What did they do correctly? They did the X and the plus 1 part correctly. Okay. So that's how you're doing these problems. All right. All right. So check your work. So what did they do correctly? Well, they did the negative 5x and the 3 correctly, right? But they got this first part wrong. Okay, so you see how there's a negative chilling out front? So if I plugged in negative 2, that would be negative 2 squared, which is 4. And there's a negative still out front, so it would be negative 4. If this would have just been x squared, then that would have been fine. It would have been positive 4. But since there's a negative already there, we keep that guy negative. Okay? That one's a little tricky. Go ahead and try that last one. On this one, Liana did the first part right, she did the second part right, but then she did this last part wrong. She didn't multiply, she added. You have to make sure that you're paying attention to what they're asking you to do. Okay? Once you're finished with that, go ahead and flip over to the next page, and I want you to think about how can using a table help you graph quadratic functions. Okay? Once you're done with that, then you're going to do the cool down, so down at the bottom. So take a moment, you got 3 minutes to do that next page. Okay, so how can using a table help you graph the quadratic functions? It can give you a better understanding of what exactly? Okay. All right, so we can plot points. We can see what the x-intercepts are. We can see when the y-intercepts are. Okay, so that can help us kind of figure out what the shape is going to look like, right? Okay, on the next part, it says cool down. And here are 3 statements. One of the statements is a lie. Which one is it? Okay, so the point, negative 2, negative 5 is on the graph. So if I plug in negative 2 into this equation, do I get negative 5? So let's look. 2 times negative 2 minus 1. Negative 2 plus 3. So I'm going to multiply those together. So that's going to give me negative 5 times 2. That gives me negative 10. So is that true? Oh, I'm sorry. I take it back. I was doing that too quick. This gives me negative 5 times 1, which is negative 5. So the first one is correct. On the next one, I'm plugging in 0. When I plug in 0 into this equation, I get negative 1 here. And over here, if I plug in 0, I get 3. So what's negative 1 times 3? Negative 3. So this one is correct. On the last one, if I plug in 2, this is going to give me 3 times 5. 3 times 5 is 15. This one is the lie. So I'm going to put the cards up on the board, and we're going to decide whether they're in factored form, standard form, or neither. Okay, remember, factored form is going to be these parentheses, and they're going to have like x plus some number times x minus some number. Standard form is going to look something like this. Okay, if it's neither one of those, then it's going to go in the neither column. Okay, so I'm going to put these up on the board. Give me 2 seconds. We're going to decide whether or not this is factored, standard, or neither. Okay, so on that first one, the first one, is it standard form, factored form, or neither? So remember, standard form is going to have that ax squared. So this is going to be standard form. This next one right here, is that factored or standard? That one's going to be factored. Okay. I want you to take a moment. I want you to see how many you can write down that are either standard, factored, or neither. This is on that second package or second packet that you picked up today. Yeah. Okay. This one right here is neither. Okay. Okay, so kind of thinking through this. This one on the right, is this factored or is it standard? Is this factored or is it standard? Is this factored? Okay. Is this one factored or standard? This is an exponential. This is neither. Okay. What about this one on the left? Is that factored or standard? So is it have parentheses? Is it broken down? No. Okay, so this guy is in standard. Okay. This one up here is factored. Okay. This one down here, is that factored or standard? That one's standard. Now the middle one is a little tricky. This is a different form that we have not talked about yet. However, this is neither factored nor standard. Okay, so the next part, it says set B, E, and H aside. So we're not going to look at this one, or this one. Okay. We're really going to kind of focus on this first column. We're going to look at these three equations. We're going to use those to match the graphs with those equations. Okay, so if we took this first one, which is x squared minus x, and then is it plus 6? I think that's what it was. Nope. I do. I have a lot. Got so many tabs and they're not labeled. We love it. There it is. Okay, so x squared minus x minus 6. Okay, so this is what it's going to look like. Well, what is our x-intercepts on this one? -2 and 3. Which one of those graphs, the first, second, or third, matches up with that one? The first one. All right, let's check our vertex as well. Our vertex is 0.5 on a -6.25. So does that match this one? So does this graph match up with one of those graphs? Does it match the first one? We'll look at the vertex. Okay, does it match the last one? The vertex is the lowest or highest point. Our lowest point is 0.5, -6.25. Our y is about our lowest y value. It's the last one. Okay, so on your paper, you're writing this equation for that last one. So you're writing x squared minus x minus 6 for that last box. Look at this next one. I'm going to take this and I'm going to plug it in. They're the same one. Okay, so is that the answer? Well, we could just write that in our box at the end too, right? So on your paper, where it has all of the open boxes, Okay, so down here, you're gonna write those two equations down here. So you're gonna write x squared minus x minus 6, and then x plus x plus 2 times x minus 3. You're writing both of those equations. This is the standard form, and then this is the factored form. Okay, looking at this one down here, we know that this is going to be facing downwards, right? How do I know that? Well, this negative that's chilling out front makes a parabola face down, okay? Are there any other ones that face down? No. So this is the one that's going to be in the middle. Okay, so again, if it's negative, it faces downwards. Okay, so we're going to take this one and we're going to plug it in. We're going to get x plus 2 times 2x minus 6. So x plus 2 times 2x plus 6. Is it minus 6? Okay, cool. So is that the same thing as, is that the same thing as the first one? Yeah. Okay, so go ahead and write that one down in that box. Hey, do you notice anything between these two tables? They're the same. Okay, so again, this is the factored form. I'm sorry, this is the standard form. This is the factored form.
They both have the same answer.
So if you actually graph both of these, they would overlay. They would lay on top of each other. Okay. So what's similar? They are the same graph. What's different? They're written in two different forms. Okay. So if you took this factored form and you actually multiplied it all the way out to find like terms, you would get the standard form. Okay, so let me say that again. If you took the factored form and you multiplied it all the way out, you would get the standard form. Okay. All right. So what I would like for you to do, yep, we're not done. Okay, go ahead and take a moment. Okay, go ahead and take a moment and look at the lesson synthesis page. Answer those two questions. So it says, what makes the equation more difficult to graph? And what advice would you give someone to help them graph an equation like this? Take like 1 minute, answer those two questions. We're not done. Which one do you think is more difficult to graph? Why do you think the first one? Okay. Okay. What advice would you give someone to help them graph an equation like this? Not good decimals. Or you could use a table if need be. Okay. All right. Really quick. Your interim, as of right now, is scheduled for tomorrow. Oh, your interim is your midterm. I gave you your interim midterm review last week. I'm going to post a key online for you to study with if you want to. It is graded. It is 5% of your grade. So if I got a 0, take 5% off. Exactly. Okay.